This is part 3 of lesson 5.5. We're going to do the last problem here together, example 3. The next cup of coffee sells a special blend of coffee for $2.06 per mug. The shop sells about 200 mugs per day. Customer surveys show that for every $0.05 decrease in the price, the shop will sell 10 cups more per day. So every time you decrease the price by 5 cents, the surveys predict that you'll sell 10 more mugs per day just because it's a more attractive price. 10 more people will be interested in buying those mugs, or someone might buy more than one of the mugs. So we need to determine the maximum daily revenue from the coffee sales and the price per mug for this revenue, so for what's modeled in this equation. And then after that, we need to write an equation in both standard and vertex form. So we're looking for the maximum daily revenue. Remember, maximum means vertex. Vertex. We're looking for revenue. So let's define our variables. For part A, let's define our variables. Let's let R be the total revenue, meaning how much we make. And let X represent the number of 5-cent decreases. We wrote 5 cents this way to represent it as dollar amounts, so our answers will be in dollars rather than cents. Number of 5 cents decreases. And so what we're going to do now is we're going to write an equation that will allow us to find the maximum through a vertex. That equation needs to be quadratic. It can't be like grade 9 where you're doing y is equal to mx plus b. We're actually going to get a quadratic equation this time. So we know that our revenue is going to be equal to the price of the mugs, times the number of people or number of mugs sold. And so you might already be getting the idea that you're probably going to get a factored form here based on the way I wrote this out. So let's go write that with the numbers there. We know that the revenue is the price of the mug. So the price of the mug right now is $2.60, but we're doing a model. We're trying to see what will happen when we decrease that price by 5 cents, and how many times we need to decrease it to get a maximum sale and maximum profit here. So 0.05x. So 2.60 minus 0.05x, so that's every drop in 5 cents. That's the price now. The price will vary depending on how many times we drop the price. If we drop it once, it's $2.55. Drop it twice, $2.50. Times the number of mugs sold. So we know that usually at $2.60 we sell 200 mugs per day. But if we decrease the price of the mugs by 5 cents every time, that will lead to an increase in 10 mugs for every one of those decreases. So every time we decrease the price by 5 cents, we're going to increase the sales by 10 mugs per day. So right now this is our total revenue per day. That's our equation written out. And we need to find the maximum daily revenue, which means the vertex. So this over here is our factored form. We can use the zeros to find our vertex. So let's go find the zeros first. So what we'll do is we want to find the vertex. But first we need to find our zeros. So basically, when is this equal to 0? And when is this equal to 0? So we'll do that over here. So we have 2.60, 2.6, minus 0.05, x is equal to 0. You can send this to the other side by doing the inverse operation, so adding it, and we get 2.60 is equal to 0.05 x. You can divide that by 0.05, both sides. Cross the 0.05 out, and 2.60 divided by 0.05 is 52. So one of our zeros is x is equal to 52. And our other zero is going to be, from this value over here. So 200 plus 10x is equal to 0. Isolate the 10x by doing the similar steps that we did in the previous example there. So negative 10x is equal to 200. You might have sent the 200 to the other side instead. You'll get the same result when you divide in the end anyways. You could try it out, see if that's true. And we get negative 20 as one of our other zeros. Now that we have both of these zeros, we can go ahead and find our vertex by finding the axis of symmetry and then finding the k. Before we do that though, what do these zeros actually mean? Well, those zeros are essentially our break-even points. So it's the point where we're not going to make any money, we're not going to lose any money. Those are our break-even points. So if we sell 52 mugs, we're not making, we're not losing. Now, we need to find the axis of symmetry because that's the x value of our vertex. So next we're going to do, so here we had our first step was writing an equation out. Our second step was really finding our zeros. Our third step is going to be find the axis of symmetry. By just adding the zeros up and dividing by 2. So 52 plus minus 20 divided by 2 is equal to 32 over 2, which is equal to 16. So when we sell 16 mugs, or I should say, when we drop by 16 mugs, or by 16, when we drop the price 5 cents 16 times, that's when our revenue will be maximized. So, but what is that revenue? Let's take a look. So I misspoke in part 2 here. This X doesn't mean that we will sell 52 mugs. What it means is, if we drop the price 52 times, by 5 cents, 52 times, that's when we'll basically break even. We won't make or lose. That's what that means there. So let's do that here though. So it says that if we drop the price 16 times, we should have a maximum value. This is the number of decreases. So you really have to be careful when you're interpreting the problem. So even I made a little error there when I was interpreting it because I was just doing it pretty quickly. Again, this is the number of decreases, not the number of mugs sold. So 16 decreases will result in a maximum value. What is that maximum value? Well, let's figure that out now. So we found this here was our H in the vertex form. That's your axis of symmetry. The axis of symmetry is always your H. So now using your H, find K, which is the max value. So we really just need to plug in the 16 into our equation, and then we can find our K, our max value. So what I'm going to do is this. I'm going to write R is equal to 2.60 minus 0.05 times 16 200. So times 200 plus 10 times 16 is equal to, so let's put that in our calculator. We have 0.05 times 16, and then we do 2.60 minus that, so that's 1.8 times 200 plus 160, so times 360. Multiply those together and we get 648. So we write our therefore statement. Therefore, the maximum profit is $648 at a price of, now don't put $16 per mug. This is how many times you've dropped it. So the price is really this here. The price is a 2.6 minus 0.05 times 16. So the price is $1.80. $1.80 per mug. There's a point where if you decrease the price too much, you'll obviously be in the negatives, and you don't want that. So what we did is we simply found our equation in the factored form. We found our zeros, which allowed us to find our axis of symmetry, which is our H value in our vertex. The zeros represent our break-even points. So with 52 drops, for example, you'll be doing the you'll be breaking even, you'll be making money or losing money. We don't want that. We want to see what the maximum profit can be. So let's say a ideal number of drops where we can drop it enough and get the right number of customers without losing, and we're making most. So we found our axis of symmetry is x is equal to 16. That's the x coordinate of our vertex. It's not the price, but it's the number of drops, the number of 5-cent drops, so 16 of those. Which means that if you plug it into your equation in the end, your maximum revenue would be 2.6 minus 0.05 times 16 times 200 plus 10 times 16, which gives you 648. So $648 per day would be the maximum revenue when my mug costs $1.80. So it was a $2.60. If I bring it down to $1.80, then it'll be my maximum return. And I know you're thinking, well, how can you make more if it's less? Well, again, because every time you drop it, you also get an increase of 10 mugs being sold. So that was the first part, the more application-based piece. In the last video of this section, we're going to just do part B, where we have to write an equation in both the standard form and the vertex form to model the problem. And then we're also going to briefly, quickly sketch the graph for this as well.